Today we'll solve some GATE previous year open channel hydraulic questions. So previously we have solved lots of question, around 15 question in the different 3 or 4 lectures. If you want to visit, please go in the uh, same YouTube channel and you can see. So now we'll start from the question number 16. So what is actually the question number 16? A circular sieve of 2 meter diameter. The diameter is given 2 meter, has to carry a discharge of 2 meter cube per second when flowing nearly full. It means nearly full means not pressurized flow. Here nearly full means the just indicating it is a open channel flow, like that. So we can consider, for calculation point of view, the water is flowing throughout the depth for calculation point of view. What is the minimum required slope to initiate the flow? So minimum slope you need to require to initiate the flow, or Manning's roughness coefficient is given already 0.015. So here very interesting thing, you know already the Manning's roughness coefficient has dimensions. This is not a dimensionless number, but nowhere the dimension written. I don't know why, but it is a dimension number, not dimensionless number. Okay, so now moving ahead with our problem. So we need here the minimum slope. So we know one formula, that is the Manning's formula. Velocity is equal to 1 by n r to the power 2 by 3 and s to the power 1 by 2. From here we can calculate very easily s value. So Vn r to the power 2 by 3. So what will be the r? R is nothing but d by 4. How it will come? Area by perimeter. So pi by 4 into d square divided by perimeter. How much? Pi d. So here you can get d by 4. So how much d? The diameter is 2 meter divided by 4. That means 0.5 meter is r. So s is equal to nothing but your discharge is given. So how you will calculate velocity? So discharge is equal to area into velocity. So your velocity will come out 2 meter cube per second divided by area. Area how much? Pi by 4 into d square. D square your 2 meter is 2 square, right? So your area will come out, or your velocity will come out 0.637 meter per second. So you need to put here 0.637, n value is 0.015 divided by r to the power, that means 0.5 to the power 2 by 3. So you can calculate very easily, but you need to, how you will calculate through the your GATE calculator. So you need to go through some, basically you need to practice. First of all you will solve this one, then you will solve this one, then you will be divide, then after you will use this one. Directly you can also use your GATE calculator, but you need to be the very practically you need to you need to more practice with the GATE calculator, then you can very easily solve this expression directly also through the GATE calculator. So your answer will come out 0.0023. So this is the slope. Now moving ahead on the next question, your option A will be the correct for this. Next question is about a trapezoidal channel with bottom width 3 meter. The bottom width is 3 meter, okay, and the side slope is also given. Side slope is how much given? 1 vertical and 1 vertical, means when you will move 1 vertical, maybe upward or downward, so you need to move 1.5 in horizontal. So it means what? If you will move 2 in vertical, you need to move in what? Horizontal 2 into 1.5 means 3. If you will moving 1 y meter vertically, you need to move horizontally y into 1.5, right? So again in question what is given? Now come on the main question. So your width is given already 3 meter, bottom width. Always remember whether it is bottom width given or the top width given. And your discharge is coming out 8 meter cube per second. And the flow depth is already given your 1.5 meter is flow depth. So this distance is how much? If you are running 1 meter vertically, then 1.5 meter vertically, then how much horizontally? 1.5 times into 1.5. Similarly here 1.5, and this much width is given already to you, 3 meter. So how much top width here? So your 2 times 1.5 into 1.5 plus 3. So 2 into 225 plus 3. So it will come around your top width is 7.5 meter, right? So now the Froude number, what is the Froude number of this question? So your what the Froude number? V divided by root ZD. Sometimes you don't mistake with this formula, because this formula is applicable for the horizontal or your rectangular channel, because your top width and bottom width is same. So here what is D? Actually D is nothing but area by top width. So if you will multiply here B into Y, this is Y, and this is your top width is equal to same, B is equal to T. So here it will come, D will come in case of rectangular channel Y, but here in the trapezoidal case it will be different. So how much D? Area is how much? Area, how you will calculate the area of the trapezoidal section? So let me first calculate the area of the trapezoidal section. Half top width plus bottom width into height, or so 1 by 2, and top width is 7.5 plus B is equal to 3 into how much? Your depth 1.5. So it will come around, area is equal to come your let me calculate first. So your area is coming 7.875 meter square. So now you will put in the formula. So D is equal to 7.875 divided by top width is 7.5. So your D will come 1.05. So now you can very easily calculate the Froude number. So your velocity, how much? How you will calculate the velocity? So discharge is equal to area into velocity. So your 8 divided by area is how much? 7.875. So it will come around your velocity. Your velocity is come around 1.015. Let me calculate. Let me check again. 8 divided by 7.875. Yeah, exactly 1.0158 it is coming, but we'll consider up to 3 digit after the decimal. So your velocity 1.015 divided by under root 9.81 into 1.05. So it will finally it will come, let me check, it is coming 0. Or let me check, 1.015 divided by 9.81 into 1.05. Oh, this will come under root 9.81 into 1.05. So it is coming 0.316. So here is option is no one matching, so it means all options are wrong. In such type of question, in any exam you will get all student will get the equal marks for that. Okay, so in a line rectangular canal, the Froude number of incoming flow is 3 meter. A hydraulic jump form when it meets the pool of water. The depth of flow after the jump formation is 1.51. The Froude number of flow after the hydraulic jump. So the question is given, the jump will form, and here is section 2, section 1. Here fr1 is given 3 and fr2 you need to calculate, but depth is given at the fr1. So fr2 you need to calculate. So what is the relation? Relation you already know, y1 divided by y2 equal to 1 by 2 1 plus 8 fr2 square minus 1. So from here you can calculate fr2 if somehow you will calculate y, the ratio of y1 and y2. So one, you can also write this formula like that, 1 by 2 1 plus 8 fr1 square minus 1. So from here you will calculate y2 by y1 ratio, it is 3.77. So you need to put in this equation. So it will, when you will put, that is your y2 divided by y1 ratio 3.77. So y1 y2 ratio is 3.77. So now you can put here 3.77 1 by and 1 by 2 root under 1 plus 8 into fr2 square minus 1. So it will come fr2 your 0.41. So option C is correct for that. Now moving ahead, question number 19 and 20. A very wide rectangular channel carries a discharge of 8 meter cube per meter width. Okay, so discharge is given 8 meter cube second per meter width. The channel has a bed slope of SD 0.004. The Manning's roughness coefficient is 0.015. At a certain section of the channel, the flow depth is 1 meter. Let's say anywhere. This is the channel. At a particular section, water is flowing like that. At a particular section, your depth is somewhere water is flowing like that, but we don't know how much water is flowing, what is the surface profile of the water, but we are virtually, I can draw here, the 1 meter is the depth at a particular section. So what gradually varied flow profile exists at this section? So we need to calculate the gradually varied profile, whether it will be S1, S2 or S2, S3, M2, M3, or what will be your profile. So how you will calculate? For that you need to calculate first, you need 3 data. What 3 data? Normal flow depth, how much your flow is occurring, that is y currently, and what is your critical depth. Then you can, comparing these 3 things, you can easily calculate whether it is M2, M3, S2, S3. So now moving ahead, so how you will calculate your normal depth? So discharge is equal to, you know already, 1 by, for a rectangular channel, so 1 by n and yn to the power 5 by 3, 5 by 3 and s to the power 1 by 2. So how it will come 5 by 3? Let me very quickly cover here. So your velocity formula is 1 by n r to the power 2 by 3 s to the power 1 by 2. So your discharge is equal to area into velocity. So you need to put here your velocity formula. So it will come n r to the power area b into y divided by area by perimeter b plus 2y 2 by 3 is to the power 1 by 2. Here is a wide rectangular channel. Wide rectangular channel means your b is bigger y. So here we can write only b at the place of b plus 2y. So we can write only b. So b cancel. So your actually formula will q divided by b. This b will become down and into 1 by n and y to the power 2 by 3 s to the power 1 by 2. So 2 by 3 plus power 1 here, if you will add these things, you will get the y to the power 5 by 3. So now put the data. So your discharge is equal to 8 meter cube per second, equal to 1 by n. N is nothing but 0.015. It is already given in the question. You need to calculate yn 5 by 3 and s already given in the question. So what is s here? S is your nothing but your bed slope. So your s value is 0.004 to the power 1 by 2. So you will get yn is equal to 1 meter. Now let me calculate yc. So yc, how we will calculate yc? So your yc is know already, q square divided by g to the power 1 by 3. So what is the q square? Q square is nothing but your 8 square. 9.81 power 1 by 3. So it will come your yc value 1.868 meter. So now you compare these three things. So your y value is 1 meter and yn is coming 1.468 meter. So it will be greater 1.468. Then after your yc is also greater. So yc value is 1.86. So how look like your profile? So this is the normal bed, and this is your critical line, this is normal line. So your flow is here, this is the yc, and this is your yn, and your flow is somewhere here 1 meter. So in 1 meter, so your flow will, in case of, so here the region is how much? The S1, S2, and this region is known as S3. So your flow in which region? Your flow in S3 region. So this will be correct, because your flow always flow try to reach out the always flow try to reach the normal depth. So from here your flow will reach out the normal depth like that, normal line. So normal flow it will be getting. So here your flow profile is S3. Always remember. If you need more explanation on that, so I can take a long class, theory class.